Okay, so I just started the recording, and
That scared me. I was like, what the hell is going on with my phone?
Oh, wow.
Do you want to trust this computer?
This is so good.
This is very cool.
Cool. All right, so now we're watching my iPad, which I can write all over, right? So, yay. Okay, so for the most part, we're not going to know any more information until April 3rd. That's when the College Board is going to release some more information about what's going to be on the test and what formats and all that sort of stuff. DCPS has asked AP teachers to ask students who does and does not have computer and internet access. So while I think the College Board is trying to set it up to where this test can be taken by anybody on any device, I think it's going to be best if it's done on an actual computer and not a phone or a tablet. Like, I can't imagine trying to take a test on a phone. So I think everybody in here has a computer, correct? Everybody is joining me from a computer or a tablet.
Yeah.
Well, I have a computer, but you're on my phone.
Yeah, you're on my phone.
Okay, that's fine. But you do have a computer. So if for some reason over the next week, like your computer is freaking out, it's like, I just literally cannot handle this much internet connectivity and activity, please let me know. But I'm reading the tea leaves here and seeing that since DCPS is asking who needs computers and internet to be able to take this AP test, our AP test is May 7th. They have technically only closed access to the schools through April 24th, but the test is May 7th, and they're asking who needs computers to be able to take this test at home. So I'm guessing I'm not going to see you on April 27th. Just saying.
Oh, wow.
What the?
I really don't like this.
Sabotage.
They're just setting us up.
Oh, God.
No, because what they're doing is they really are trying to just do things in chunks. So I think if they make a decision to extend this beyond April 24th, it will be the last announcement that they'll make, and they'll have like a how we're wrapping things up sort of announcement. But we're not there yet. So right now they just bought themselves more time to be like, okay, so, this is going until April 24th, and we'll return to the 27th. That gives us 5 weeks to figure out what's actually going to happen. And Virginia gets to lead the way there, because Virginia just said that they're not returning to buildings this school year at all. So we can kind of look and see what those school districts decide to do, if they just continue distance learning all the way through the end of the school year, or what. So with that being said, I just really don't think we have any idea what's going to happen. So we'll just plan the best we can, right?
This is a mess.
It's a lot. It's a lot, and I can't imagine that it wouldn't be a hell of a lot better if we had different leadership going on. But
I agree.
Yeah. So if you're 18 by November, please vote.
Oh yeah.
That's really all I can say. So anyway, so for this week and next week, we're just going to wrap up this solubility unit. So we'll do small chunks of 4.4 today and Friday, wrap it up on Monday, do a couple of practice free response questions on Wednesday of next week, and then I'll set up a quiz in AP Classroom for you guys to do, since that's clearly the platform they're going to use for the modified exam. We just need to get used to seeing how it looks like to do free response questions on there. And so that's what we'll do. And then that should get us closer to April 3rd. I do want to do some of the acid and base material that I gave you, just because some of it does tie into previous things and we can use it as a review. It's a good math review, help us look over Lewis structures, a little bit more equilibrium work. And then we're just going to pretty much jump into review. And as I was telling, I don't know who asked me yesterday or the day before, my understanding is that the school is going to be opened one more time, and I'm going to try and get your big binders brought upstairs so that whenever that next pickup is, that you guys can come and pick up all of your materials. I don't know if that will involve allowing people into their lockers or not. Like, those are the sorts of things I just really don't know, but I can get anything in my own classroom. So if you do have a binder of materials in my class, I can probably try and get those for that next pickup, whenever that is. I think it's around April 1, so April Fool's Day.
This whole thing is a big April Fool's joke.
Yeah, it has to be.
Yes, so Catherine and I are coexisting as best we can, both working in the space. I am here in the basement. This is my lovely basement. So that's our spare fridge that I fill with food because I'm a cooking person. You can see my periodic table behind me that I got from Amazon last week. And then,
oh, how cute.
Yeah, there's my bike. And, so you can see that bucket of materials down here that I pulled, I went up to the school on Monday and grabbed a bunch of stuff. And that's my jigsaw table and the puzzle back behind. And again, it's my kitty. He's looking at us. Oh, girl. He's very skittish. So, okay. So let's get started with this actual thing. So looking at the warm-up here. Everything that we've done so far in this section has been looking at taking the solid of the salt and dumping it in water. And when you do that, we know that you would get, oh, hi, Kyle. AgCl would then split up and it would do this, right? We're getting our dissociation. So in that situation, how does the concentration of these two ions compare?
They should be the same.
They should be the same. And they should be the same because it's a 1-to-1 ratio, right? From the coefficients. Because they're coming from the same place. They're coming from the solid and going into the ion. So that's what we've been dealing with. With this section, we're talking about something different. So what if I took some flask that had Ag in it, and I took some flask that had chlorine in it, and I dumped them into a beaker? So what if I took them from two different sources? And now instead of trying to start with a solid and get ions, we're going to start with the ions and see, do we get a solid?
Yeah, we should.
Okay, well, it depends on the concentration. So looking at number 2 here, it says if a student mixed 25 milliliters of 0.1 molar silver nitrate, right, so AgNO3, and 15 milliliters of 0.085 molar sodium chloride NaCl, calculate those concentrations of the chloride and of the silver, and the word here is of the mixed solution. So what formula do you need to get this going?
The constant
NaNO3?
No, what formula? What math formula?
Like the
Oh,
is this the
okay.
M1?
Yeah, Jackson, I heard it. M1.
M1.
Whoa.
What is that?
What What the hell is going on?
No, somebody with two devices on. Okay, so how many times are you going to have to do this?
Twice.
Twice.
Yeah,
Okay.
twice.
So what's your new volume? Your V2?
40.
40,
Yeah.
right? So you've got the 25 and the 15. Okay, so go ahead and set that up. Do it twice, and let's figure out what the concentration of the Ag is and then the concentration of the chlorine.
Can we leave it in milliliters, or does it have to be in liters?
If you're an M1V1, you can use it in milliliters.
Okay.
Yep, I got both of those.
Is that what you got?
Mm-hmm.
Yeah.
Are those the same number?
No.
Oh.
No, they are not. Because those two things are completely independent of each other, right? Like you are mixing them separately.
Mm-hmm.
So which one do you have more of?
The
Nitrate?
Ag nitrate.
The Ag, right? The silver. Now, do we actually care about the nitrate or the chloride here?
No.
No.
Well, we have
No.
the.
I mean, not, we do care about the chloride, my bad.
Yeah.
The sodium. What are those things?
What's it called? Spectators.
Spectators. Okay, good. Okay, the net ionic equation for what we just did, if we dump these two things together, well, it's the exact same thing, right? It's essentially that in reverse. I took Ag as an aqueous solution and chlorine as an aqueous solution, and I made AgCl as a solid. No sodium and no nitrate because those are the spectators. So we're still dealing with this same environment of stuff. So looking down here at the bottom, again, what we are focusing on is forming precipitates when we're mixing solutions. And the thing to remember is that you're just going to have to use M1V1 equals M2V2 with the new mixed volume. So you're going to have to calculate that new volume to be able to do these calculations. So it's like I said, it is the reverse of what we've been talking about. Instead of taking a solid and trying to dissolve it, we're taking solutions and we are trying to see, does it actually form a solid? So to predict that, what we are doing is doing a comparison of K and Q. So remember that we had Ksp, and now we're going to call this Qsp. Okay, and we had three different possibilities here. they could be equal. You can have Q be smaller, you can have Q be greater. So looking at this, if these two things are equal, then you are what's called at saturation. And when you have an actual saturated solution, it's like you can almost see that there's something there. It looks so thick with dissolved stuff, but it's still clear. But it's like one tiny little change, and all of a sudden you're going to get a bunch of solid dropping out. It's not a stable situation whatsoever, but it's kind of cool. So they don't normally actually ever talk about saturation. We tend to talk about these other two conditions. So remember, if we have our arrow or greater than, less than sign pointing that way, that's saying you've got this, right? You're going forward. And if we're talking about these kinds of reactions, does forward mean more ions, or does forward mean more solid?
More solid.
More ions.
More ions.
Oh yeah, because we start with the product.
Yeah, you start with the solid and you're trying to see, does it dissolve? So more ions, meaning it dissolves.
I thought
Right,
we were
because
still going the other way.
Well, when you mix it, yes, but so again, that's our basic, thing, right? Ksp is Ag plus and the Cl minus. So going forward means more ions, meaning you're going to get more of it to dissolve.
Yeah.
And so it's this backwards. When Qsp, when Q is greater than K, you get a solid forming.
Okay.
Are we going to 11:30?
What?
Are we going till 11:30?
No, 10:45.
Oh, okay.
Yeah, I'm only doing 45-minute classes because nobody actually wants to sit on this computer for that long. I mean, if we're honest.
Yes.
So, yeah, so I'll treat this basically like a bunch of Monday classes of just me doing some examples and stuff like that. And then there's the office hours if you have any questions about other stuff. So, okay. So when the chapter actually says this thing, this TIP, yeah, nobody uses that. It's QSP, like that's what everybody refers to. So let's turn the page and blink. I love this setup on my computer. Okay. Okay, so kind of over in this spot over here, I wanted to actually write out the steps. So in this kind of problem, the first step is always figuring out what solid could form. Now, on the AP test, because you don't have a table of reference values to look at, they have to give you the Ksp, so you know what solid is going to form because it's going to be whatever they gave you the Ksp for. So that's helpful.
Wow.
That was a good sneeze, Nala.
Thank you.
And then, like always, once you figure out your solid, you write out your dissociation equation, right? So you write dissociation equation. And then we're still going to write out our Ksp, right? Right, the expression, remember equation and expression, not the same thing. So the expression is the guy with your little brackets. And then you're going to use M1 V1 equals M2 V2 to get new molarities to plug in the Ksp expression. So that's actually the only new step, right? Everything else we've already done, like write out the write out the equation, write out the expression, and then you'll. So once you plug in those concentrations, all right. So you plug in and solve, except now you're not getting KSP, you just found the Q. And then the last step is to compare. And again, when we compare, we do it alphabetically. All right, so compare the KSP to the QSP.
Ms.
So,
Baskin,
yes.
number 4 says use M1V1 equals M2V2 to get new.
Molarities.
Thank you.
Mm-hmm. It's a little hard for me to write on the far right side of the iPad, so.
Ms. Baskin, number 5 says plug in and solve because I can't see the rest of the screen.
Oh, it says plug in and solve, and that's QSP.
Okay, thank you.
Mm-hmm.
And when we do this, what are we doing?
You're trying to figure out if a solid forms. Like, that'll be the question.
Okay, cool.
They'll ask you, if I mix these two things, will a solid form? Justify your answer or prove it through calculations or something like that.
So these steps are how I figure out if a solid has been formed.
Right. So this is I am mixing two things. Will a precipitate form?
Okay.
And Miss
Thank
Baskin,
Yes.
when you find the new molarities using the M1V1 equation, plugging in those new molarities to the Ksp expression, that gives you the QSP.
Yes.
Okay.
Right? Because remember, Q is just K that's not at equilibrium.
Yeah. Okay.
Oh, haha.
Uh-huh. Okay. So let's try practice problem number 1. Okay, so it says, will a precipitate form? And again, precipitate just means solid. So are we going to form a precipitate when 8.5 milliliters of that molarity of lead 2 nitrate is added to 1 liter of 1.2 times 10⁻³ sodium iodate? So the first step is, again, figuring out what is the solid. So out of those 2 compounds, what's going to come together to make the solid?
The PP and sodium. What's that?
Lead.
The lead and
iodate.
iodate.
Yeah.
Yes.
So
You have to have
this is what I'm saying. They'll make it very obvious what solids this is why we don't need to know the esoteric solubility rules, because nitrate is never going to make a solid, and sodium is never going to make a solid.
Okay.
Okay, so we know that the charge of the lead is 2. Iodate is just chlorine with the iodine, or is just a chlorate with iodine instead of Cl. But again, even on the AP test now, they would even give you this formula, right? So it would be Pb IO3 2. And again, on the AP exam, they have to give you the KSP because you don't have that. But in here, you would need to look that up, but I'm going to give it to you to save time. So here, the KSP is equal to 3.7 times 10⁻13. And if you'll remember in the last section, 4.3, there was a giant chart of them. That's where I pulled that number from. I didn't get it from anywhere else. Okay, so I've got my solid. Now I need to write my equation. So I've got Pb IO3 2 making Pb2 plus IO3 minus, but you got to remember there are 2 of those. All right, because that 2 becomes that 2. Okay. All right, and the next step was to write my Ksp expression. So brackets, Pb2 plus, brackets, IO3 minus, squared, because again, right? That 2 becomes that 2 becomes that 2. That's how that all works together.
Mm-hmm.
Okay, so now I've got that. Now I need to solve using M1V1 for those new concentrations.
Excuse me.
Let's do. Okay.
My voice is like going on.
So what is my new volume? What is my V2?
I have to convert one of those to one of the other ones.
Yeah, you got to keep them the same. It doesn't really matter which one you.
So would you?
I would put the liters into milliliters because otherwise you're working with a big decimal, but it doesn't matter.
So that'd be 1,008.5.
Yes. Okay. So then let's go ahead and tell me what is my. So you solve and tell me what is my new concentration of lead, and then what is my new concentration of iodate. So you've got your V1s and your M1s already there in the problem, and we just found the new V2.
I get it.
Yay!
V2.
Okay.
Wait,
And
okay.
Yes.
So if we're doing the separate M1V1 things, do we have to change it? Do we have to change the volume units in the individual equations? Or can we leave them as they are?
So if we use V2 as 1008.5, then for the iodate, you're going to have to use that 1 liter as 1,000.
Okay. Okay.
But the lead is already in milliliters. And pay attention to your sig figs here. You should only report 2 places for your molarities.
Oh, Miss Baskin, did you see that I have 2 of your calculators right now?
Yes, I did.
Okay.
Yeah, I was just trying to keep those yellow ones since those are the ones that the school had recently bought. I was just trying to keep those at home, but that's fine as long as I know where it is.
Forgot how to use calculator for a second.
And those ones I sent home with you, I think I put fresh batteries in all of them, so they should be good.
Yay.
Is that what you guys got for the concentrations?
Mm-hmm.
Yeah.
Sure.
Sure.
Wendy?
Wait, I write slow. Just hold on.
No,
Yeah,
fine.
I got that one for the PB.
But this is also why I'm recording this, right? So when you're going back, you can watch us go through it again.
Yeah.
Yeah.
So, Miss Baskin.
Yes.
When you for the iodate, did you already square it?
No.
Okay, no, this is just okay.
Yeah, so that is literally just what is the concentration when I put sodium iodate in water.
Mm-hmm.
You know, like this is what it would be, right?
Mm-hmm.
I'm just diluting. So.
Mm-hmm.
Okay.
Wait, are you guys converting the 1.0 liters to milliliters or the 8.5 milliliters to liters?
I did that, the first one.
Yeah, I did liters to milliliters.
Okay, cool.
Wait.
Okay. So once you have those concentrations, now you plug them in to solve for Qsp, which is just putting them into the Ksp expression. So my PB is the 5.3 times 10 to the negative 4th. And then my iodate, 1.2 times 10 to the negative 3rd. Now we square that.
Mm-hmm.
Okay. So The hardest problem here is actually, as Jordan always says, getting the calculator to do what you want it to do. It's like, I know what it's supposed to do. Now I need the calculator to cooperate.
Ooh, don't do me this Baskin.
No, but it's so frustrating for you. I know, because I look and I see it's like, no, you've set everything up right. I don't know what's happening.
Right.
So sometimes what's easiest is to actually take these out of scientific notation when you're entering it into the calculator. But regardless, let's see. And this should still be just 2 sig figs. But when I did this.
Wait, I have a question.
Yes.
So the KSP at the top is 3.7 times 10 to the negative 13. What did you do with that?
Nothing yet. I used that in the very last step.
Okay, all right.
I'm just saying that they'll have to give that to you.
Oh, well,
no
we gotta
way.
compare it. Okay.
Yes.
Okay. All right, makes more sense.
Okay.
I got 7.
Okay, yes, I got that. Yay!
I did it. I'm so proud of myself.
I'm sorry, Taylor.
right now.
You're fine.
Okay, so in this instance, if I'm comparing KSP and QSP, which of those numbers is bigger, 3.7 times 10 to the negative 13 or 7.6 times 10 to the negative 10?
7.6 times 10 to the negative 10.
Yes, the negative 10, right? The negative 10 is bigger than negative 13. That is another thing that can make these problems tricky, is because you're dealing with large negative exponents. And so since they're the negative exponents, it's kind of the opposite world you got to remember. But if I am going this way, what does that mean? Am I making solid or am I staying dissolved?
Yeah,
Making solid.
I'm making solid.
Yay, guys, we're learning. Yay.
Oh,
Yes,
so
Baskin.
I get the QSP value when we compare the KSP. We go not back, but to the thing that we were talking before. Yeah, okay. Yeah, because I was wrong. Yeah. Makes sense. Thank you.
Okay, so let's get the next one set up. So for the next one, which 2 things are going to make my solid?
I'm sorry, Ms. Brown, I have a question.
Yeah.
So when they're equal, what does that mean?
That means you're at a point of saturation. They're never going to ask you for anything equal, because when they're equal, that means you're at equilibrium. They're never going to ask you for that.
Is it the silver and the bromine?
It's going to be the silver and the bromine.
Period, because ammonium and nitrate never make solids.
Yay, there you go. Bam, bam. Bam, bam. Okay, so silver bromate.
Is it always going to be like the first and the last of something?
Yes, because you have to have one cation and one anion to have a thing.
Go Nala.
One key.
Yes.
All right, so silver bromate, and the value of that KSP is 5.3 times 10 to the negative 5th when you're ready for that step. And then what is your new V2 here?
122 milliliters.
No.
Yep.
One. Yeah, wow. I can't do basic addition. Wow.
You can still get to use this.
Okay.
Okay. Okay. So I don't want to take tons more time. So I will just tell you that this, when it says will a precipitate form, the correct answer here is no. You do the math and see if it works and see if that's what you get. And then if you want to do number 3 as well, it tells you that no precipitate forms when you mix all of that stuff. And it's asking you, what can you conclude about the value for this? Well, if I get no precipitate, which one is greater?
Okay.
K, right? That means no precipitate. So that means that whatever value for you get for Q, you're going to know that K is bigger than the value you solve for Q.
Wait, can you repeat that, please?
Yeah. So it tells you that no precipitate forms. That means no solid. No solid means that K is bigger, because this means if I'm going this way, that means I'm still dissolving. All right. So, and then they give me some numbers here, and from these numbers, I can calculate Q.
Yeah.
And I know that Q has to be smaller than K, because otherwise it would make a solid, and it's saying it doesn't. So I know that whatever I calculate for Q, K has to be bigger than that number. That's all it's asking you, right? That's all it's saying.
And then to state the KSP value as a range, so it'd be like greater than this number.
Yep.
Basic. Oh.
Yep. So, so that's it. That's all I wanted to go through for today.
How do I run this back though?
You finished just on time. That's crazy.
Wow.
Put it back.
What? Okay. Oh, good Lord. Sorry.
What is wrong with you? Even on this part.
Oh,
Yeah.
okay. You have eyeshadow on. You said today is the day.
Today is the right day.
I had time.
If I did.
What's the device code?
Yay, thank you.
Okay. So you guys owe me the 4.3 review questions today at some point.
How do we, are we sending pictures?
Okay, so my preference is to get PDFs from you, because it comes as one file instead of multiple separate images. And that's why I suggested a couple of different apps. Cam Scanner, Scannable is another one, Genius Scan. These are all phone apps that would let you take a picture like you would normally take a picture and send to me, but you can take a picture of the front, turn the sheet over, take another picture, and it will combine it into one file that will turn it into a PDF that you can then email me. And by doing it that way, just like I annotated this on my iPad, I can look at your problems, and if you make any mistakes, I can actually correct them on my iPad, resave the file, and save it as a link in the comment code, the comment portion of the assignment in Aspen, so you can actually go back and look at your work.
Okay.
That's incredible.
Yeah, so that's what I get to do with my afternoons is grade and annotate stuff.
What's the name of the thing again, Miss Baskin?
What?
What's the name of the app again?
Yeah, there's a bunch of different ones. So Cam Scanner, I put them at the bottom, I think, of the plan that I sent out.
Okay.
Yeah, so it's on there. And then on Friday we'll do the next little section. So we'll do the next 2 pages, 253 and 254 on Friday. And then if you, for some reason, get stuck with something on 4.3 and you have a question, I have class right after this, and then I've got office hours with my honors class this afternoon. But you can just take a quick little image and actually send it through Remind. So that works as well. I was hoping. So I was working with that, and that's fine. Oh, good Lord, who is that?
That is not me.
That'd be tragic.
I'm like, mute you all. Okay.